slide. For those of you who haven't been to Imperial County or this kind of southeastern area of California, absolutely amazing that this can happen in the desert. So I wanted to say the reason I left on this slide is the innovation of this project really started 150 years ago when some engineers, surveyors, and geologists decided, hey, let's convince the United States government to reroute the Colorado River through the Imperial Valley so that we can irrigate this desert. John is not kidding you when he says this is an irrigated desert. If you ever come here, you will drive 2 hours through brown, lifeless desert and drive into this oasis. And you can see it here on these pictures. It is absolutely amazing. I just wanted to point that out. So, to the project. I mentioned the innovation of that was done 150 years ago. Well, Valmont also is an innovator in the agricultural irrigation system. So Valmont started with their own center pivot irrigation system. To do that, to build that system, they required to fabricate steel. This was started in 1940, Valmont Industries. And then they built into a worldwide steel fabricator, now fabricating steel throughout the United States, and a AISC intermediate bridge certified steel fabricator that we deliver bridge products throughout the United States. And for this project, we delivered our press brake form tub girders, or like we like to call them, our U-beams. A little easier to say than press brake form tub girders. So we have 5 different shaped tub girders. As you can see here, they range in spans from our shallowest U12, which can get out to 40 feet long, all the way up to our deepest, our U33, that can span a full 100-foot long single span under AASHTO HL93 loading. So the press brake tub girder is a product brought to us by the Short Span Steel Bridge Alliance, and I'll talk about that in the rest of the project. So want to get into the specifics of, first of all, if you don't know what a press brake tub girder is, it's been around for about 20 years now. First project was installed in Monroe County, Michigan in 2004. It's been researched by Michigan State University, Iowa State University, Marshall University. So it's done a lot of research. And basically, what a press brake tub girder is, as you can see here, as Iowa State University defines it, is it's simply a flat piece of AASHTO M270 plate made in the USA, flat steel plate, bent into a structural shape. That structural shape is what AASHTO would call a steel box section. All the fabrication procedures and design follow the AASHTO bridge specifications. There have now been over 100 bridges throughout the United States installed, with this being the first installation in California. AASHTO has also recognized this product, press brake tub girder, with an AASHTO Innovation Initiative Award back in 2020, where it was deemed a ready to implement technology. We also were awarded a focus technology the year after. And then finally, maybe some of you have even seen, if you're familiar with press brake tub girders, back last year, Missouri DOT, Pennsylvania DOT, Michigan DOT, and myself gave an AASHTO presentation, AASHTO AII presentation about the press brake tub girder technology. So, what is a press brake tub girder and how do I design it? Well, that's a great question, and if you really want to know, I really recommend going to the Short Span Steel Bridge Alliance website. It's shortspansteelbridge.org website. At that website, you will find a 7-volume research report published by the Short Span Steel Bridge Alliance. And in that report, you'll find full-scale testing, full-scale example projects, fatigue testing, live load distribution factor verification, and complete AASHTO design procedures, which are shown here. Basically, a press brake tub girder is a term that was coined by the Short Span Steel Bridge Alliance, but basically it is a AASHTO steel box section. It's as simple as that. The NSBA, the National Steel Bridge Alliance, through AISC, will be publishing a press brake tub girder design manual. With it, Valmont will be planning to release also some design software of their own, so that you should look for that coming in the future through the NSBA Technical Resources website. So in this manual, you'll learn about how the press brake form tub girders were developed through the Short Span Steel Bridge Alliance. And as I said, there are 5 shapes, are standard, that were developed through an efficiencies study through the Short Span Steel Bridge Alliance. Why 5 shapes? Well, if you buy steel plate from the mill, there are basically 5 widths that are standard rolling widths from the mills. A 6-foot, 7-foot, 8-foot, 9-foot, and 10-foot plate. So if you can see here, the U12 is basically fabricated from a 72-inch wide steel plate, all the way up to the U33, which is fabricated from that 10-foot or 120-inch wide steel plate. So we want to get as much as we can of that flat plate used into our press brake and not waste any of the steel that comes off of the mill roll. So with these 5 shapes, we have also developed what we call our beam selection chart. So with this chart, you can get some preliminary sizing. So if you're starting a job, if you're doing a study, probably what NV5 did to start this job out was to get an idea of, okay, and we highlighted here, if I'm at a 75-foot span, what sizes should I use and what spacing should I use of a press brake tub girder? So for that 75 feet, you can go with the most efficient section, which would be 33 inches deep and at 8-foot spacing, if you want the cheapest option. Or if under clearance is an issue, like it was on this job, or you want to have additional hydraulic capacity underneath your bridge, you could go with the smallest beam, which is a U24 for the 75-foot span, but you'd use about twice as many beams. But depending on your situation, you might need that for your specific situation. All these beams in this chart meet AASHTO loading, HL93 loading. They also meet they also meet the live load deflection requirements of L over 800 for the live load deflection requirements. You'll notice that a lot of these are actually shallower. AASHTO recommends a minimum beam depth of about L over 30. You'll notice on this chart, a lot of these can be used at an L over 40 and still meet that live load deflection requirement, which is a reason why this product was so beneficial on this project. So getting to the specific project. So as Dara mentioned, why did they end up choosing a press brake tub girder, which had never been used before in California, and NV5 had never even designed before this project? Well, it fit a lot of the requirements that they needed for this project. First of all, they needed to span that full 90-foot width across that drainage or that irrigation canal. It's a little deceiving. The existing piers were left in place. We did not use those existing piers to support the new bridge. We had to, again, governed by the IID. So I found out through this project, the IID is, I'm from the East Coast. The IID is kind of like the railroads are on the East Coast. It's their property. They dictate what needs to be done over their property. And they said, we're gonna span the full 90-foot canal width. And they didn't want any of the contractors in their canal during construction. So it was a superstructure removal, but then we basically replaced an entire bridge around that existing substructure. Part of it also was we had to give, or NV5 had to allow for about 2 foot of freeboard underneath the bridge to to the existing water elevation. As you saw from the pictures earlier, that existing bridge had already settled and was restricting flow of the canal. So we had to raise the bridge up 2 feet. We had to span 90 feet. The old spans were only 30 feet. And NV5 had to tie it into to the adjacent roadway, access roadway that were right off of the approaches. So very critical for NV5 to have a very shallow depth system. Otherwise, they would have pushed the approach work into 4 different roadways coming off of this bridge. So again, through the study, they chose the U30 press brake tub girder. So again, that U30 shape is about, again, 30 inches deep, over 90 foot long. So you're still looking at that less than L/30 beam depth, span to depth ratio. But we need that very shallow depth to keep that, that raise in elevation as small as possible. You look at this also, and they could have used the U33 and maybe eliminated a beam line or two. But as Darb said, they have settlement issues or subsidence issues. So every inch they could maintain of underclearance, every inch extra, were years they could add before they needed to jack again. So it's very important to get the shallowest depth possible. So why was a press brake tub girder so effective in this situation, and why is it so effective overall? First of all, there are no welds. So as far as the fabrication of the press brake tub girder, we provide no fatigue critical details in the tension zones of the press brake tub girder. What does that mean? Basically, that means there's nothing to inspect. It's flat plate that is bent to a 5 times the thickness of the plate bend radius. You can see here on that bottom right, that picture of the different bend radiuses there. These have been tested, Sharpie V-notch tested all the way to a 1T bend radius, and found there is no loss of fatigue, or I'm sorry, no loss of toughness in that 1T bend radius. So we're very confident that that AASHTO M270 grade 50 plate is going to perform very well and have no damage when we're bending it to that 5T bend radius. Also, what that does is it helps inspection. If you think about it, what are you inspecting then if you have no fatigue critical details in tension zones? Well, really, you're just looking at the thickness of that plate. And if the thickness of the plate is all you're concerned with, well, then a very durable coating system is what you really want. And that's what Imperial County chose for this project. They chose to use a hot dip galvanized coating rather than, they could have chosen to use a weathering steel system, an uncoated weathering steel. They could have chose a 3-coat paint system, but they chose galvanizing. Why? As you saw those pictures that Darb showed earlier, it'd be very difficult to come back and do any kind of maintenance to these beams with that very shallow underclearance to the water level. So they wanted a product that would, a coating that would last a very long time, maintenance free. And that's what galvanizing gives you. So there is a project here, I'm out of Michigan. There is a project here locally in Michigan that was galvanized back in 1966. We went back out. Valmont is also a coatings company. We also galvanize. We went back out and inspected that bridge just a few years ago. It's 60 years old. We determined that the coating left on that, 60 years old, no maintenance to that existing bridge. We determined that that bridge had enough coating thickness on it, I think it was 2.7 mils still left, that we had another 40 years of maintenance-free service life on that bridge. Again, galvanizing has been proven to be a very long, durable, maintenance-free coating protection. And that's why Imperial County chose it for this project. So we get into the fabrication of these beams. So we've got the order from the county. MV5 chose to use press brake tub girders. It went out for bid, and Valmont was chosen to provide the press brake tub girders to the county. So Valmont produces our beams in Jasper, Tennessee. So one might think, Jasper, Tennessee, why? How could it be economical to bring beams all the way from Tennessee to California. I just want to remind everybody that for the AASHTO M270 plate or M270 steel, most of that is built right here in the Rust Belt of the United States. So one way or another, the steel that gets to California is coming from these three sources, either SSAB out of Iowa, Nucor, who has a few plants, SSAB is out of Alabama and Iowa. Nucor has a brand new plant in Brandenburg, Kentucky, and one in Alabama. And then Cleveland Cliffs, who are out of, I think, Pittsburgh, Pennsylvania, and and Nucor is also out of Hartford. So that steel is coming from one of those sources one way or another. And what we found, we can ship as many as 6 press brake tub girders after they are fully fabricated on a standard size trailer anywhere we want without any permits. They're not overweight, they're not oversized. Whereas if you're shipping around that flat plate, if you think about it, we produce it out of flat plate that is up to 10 foot wide, costs a lot more money, especially on these U33s that require a 9 foot wide flat plate. A lot more efficient to ship the flat plate to a close location where we can fabricate it and then ship the fabricated tub girders to the final delivery. I also wanted to mention that these beams being 90 feet long, there are not press brakes that are 90 feet long. So you have to fabricate them in pieces. The longest Valmont can do, there are many press brake, many companies out there, fabricators out there with press brakes. The longest press brake we have is a 60-foot long press brake that yields a 58-foot long single piece. So for this particular situation, this single span application, we fabricated each beam assembly in 3 pieces. The main girder piece, the middle span, the middle piece, that was, I think it was around 55 feet long, and then 17 and a half or 17 and a half, 20 and 20 to make up the difference. So you don't want to put the splice, I think all you structurals out there know, you don't want to put the bolted splice right in the middle of the span. You want to put it as close to the supports as you can to reduce that moment. So these beams, these 8 beams were all required 3 beam pieces. So we delivered 24 press brake tub girders to the job site. We delivered these jobs. Press brake tub girders can be built. Tub girders can be built very quickly. These jobs were delivered about 12 weeks after we received the purchase order. We actually delivered these beams prior to the contractor mobilizing to the job site. Once the contractor mobilized to the job site, they found that the gas main that John talked about earlier had not been relocated yet. So there was about a 4-week delay due to the utility relocation on this project. So one of the things that the contractor came up innovatively was, rather than waiting around, this bridge was designed as a single span with a cast in place concrete bridge deck. So rather than waiting around for the utilities to be relocated so that then they could start demo, as you saw earlier in Darab's photos, they set up a staging area on site and actually precast the concrete deck prior to lifting them in place. So basically, they changed this project from a normal project to an ABC project during the project, which is pretty innovative in itself. The contractor chose to redesign these beams through Valmont. They asked Valmont if that was possible, and with the help of NV5, they redesigned the beams to be a PBU units type installation, and basically got back the 4 weeks through ABC construction that they lost for the utility relocation.